Solve for all real values of x. Absolute value of x plus 5 plus 4 times absolute value of x plus 2 plus 2 times the absolute value of x minus 10 is greater than 51. So, the first thing I did for this problem is I drew a number line going from negative infinity to infinity, and this represents all the real values of x. Then I plotted 3 points corresponding to the absolute values when they're equal to 0. So when x equals 10, 10 minus 10 equals 0, negative 2 plus 2 is 0, and negative 5 plus 5 is 0. So with these 3 points, we can make 4 different intervals that we're each going to test to find all the real values of x. Case 1 is x is greater than 10. When the x values are greater than 10 inside of the equation, that means that all the absolute values are going to be positive. And when the absolute values are positive, that means that the numbers inside of the absolute values don't change any values. So they just stay the same that they are. So then we get x plus 5 plus 4 times x plus 2 plus 2 times x minus 10 is greater than 51. When we simplify this out, we get 7x minus 7 is greater than 51. So we solve for x, so we add 7, then divide by 7, and that gives us x is greater than 58 over 7, and 58 over 7 is equivalent to 8 2/7. Now 8 2/7 does not fit into the interval of x being greater than 10, and if x is greater than 10, then it's already greater than 8 2/7. This means that since 8 2/7 doesn't fit into the interval, it doesn't actually matter. So the interval stays as 2 to infinity, and that's going to be used later when in our final solution set. Case 2 is negative 2 is less than x is less than or equal to 10. On this interval, the x minus 10 becomes negative, and when the absolute value becomes negative, the x minus 10 becomes negative also. So it'd be negative x plus 10. But you can multiply out the negative 1, so then it'd be 2 times negative 1 times x minus 10. So, and this leads to negative 2 times x minus 10. So the equation becomes x minus 5 plus 4 times x plus 2 minus 2 times x minus 10 is greater than 51. This simplifies to 3x plus 33 is greater than 51. And then we solve for x, so we subtract the 33 and divide that by 3, which gives us x is greater than 6. Now, x is greater than 6 actually does fit onto our interval. And it fits in such a way, so the new interval would be 6 is less than x is less than or equal to 10. So the negative 2 gets knocked off because the 6 was greater than it. And so that interval, 6 to 10, is going to be used in our solution set later. Case 3 is negative 5 is less than x is less than or equal to negative 2. Now, on this interval, x plus 2 would become negative, just like how x minus 10 became negative, and x minus 10 would still become negative, because if you plugged in any of the intervals into x minus 10, it would still be negative. So we have x minus 5 minus 4 times x plus 2 minus 2 times x minus 10 is greater than 51. Now, after simplifying, we get negative 5x plus 17 is greater than 51. Now while we're solving for x, we have to divide by negative 5. And when you divide by a negative and a less than or greater than function, the sign switches. So instead of it being x is greater than, it would become x is less than. This gives us the answer if x is less than negative 34 over 5, and negative 34 over 5 is equal to negative 6 4/5. So case 3 will have no solution, because x being less than -6 and 4/5 doesn't actually fit anywhere into the interval. And if you try to make it fit, the interval would just look like -5 is less than x is less than -6 over 4/5, which doesn't actually make any sense. So this interval would have no solution to it. Case 4, our last case, is x is less than or equal to -5. On this interval, every single absolute value becomes negative. So we get -1 times x minus 5 minus 4 times x plus 2 minus 2 times x minus 10 is greater than 51. This simplifies out to -7x plus 7 is greater than 51. And so we solve for x, so we subtract 7, then divide by -7, which changes the sign, into x is less than -44 over 7, which goes into -6 and 2/7. So -44 over 7 ends up being less than -5. But x is less than or equal to -5 could also be written as -infinity is less than x is less than or equal to -5. So since we're going on that interval, and that -44 over -7 is smaller than -5, this means that the interval changes and gets rid of the -5. So the new interval would be -infinity to -44 over 7. So now that we have all the answers from the cases, we can start combining the different intervals. So from case 1 to case 2, we have 10 to infinity and 6 to 10. We can combine this together to make 6 to infinity. And for cases 3 and 4, there's no solutions for 3, so we just take what we have in 4. And so we can combine those and put them in order, and that means our solution set as -infinity to -44 over 7, unity 6 to infinity.